Okay, today we're talking about numbers and their value, particularly their place value, reviewing things that you've really known and worked on since elementary school there. And then we're going to have some kind of weird word problems. We're going to have word problems that talk about, well, if you start off with this two-digit number and then you switch the order of those two digits. But this is true about the numbers, and that's true. What was the original number? So those are mostly the kinds of weird problems we're going to be talking about. So before we set up for those problems, I want to review place value. And you guys know that a number like this, 496, 4 is in the hundreds digit. So what does the 4 represent? How much is that 4 worth because it's in that spot? What would we have there, Abby? It's worth 400 because it's in the hundreds place. And this one is the tens place. So what's the 9 worth, everybody? It's worth 90. We took the 90 times 10. And then I don't want to call this ones. I'm going to call it units. Because when we start in on those unusual problems I was just talking about, where we start talking about, oh, what's in the tens place and what's in the hundreds place and what's in the ones place, mostly we're going to be doing two-digit ones. So I'm going to have something in the tens digit, something in the units digit place. That does not mean T times U. That would mean 10 times whatever number is in the tens place, plus 1 times whatever's in the units place. If I called these ones and I did a T and a 0, and then I started doing this, I'm going to get myself confused and think that that's a 0. So that's the only reason why I want to call this units, so that I can use a U and not an O in there. I don't want to just confuse myself because I have trouble reading and remembering my own writing. And what you guys were just telling me, if we wanted to write that as a sum, you guys just told me, well, the 4 is worth 400 and the 9 is worth 90 and the 6 is worth 6 since it's in that units place. So if we had a 3-digit number, its value would be 100 times whatever's in the hundreds place, plus 10 times whatever's in the tens place, plus 1 times whatever's in that units place. Thumbs up, thumbs down. So far, so good. Okay, now before I actually go into that first word problem, most of the time we will be doing word problems that are mostly two-digit ones. So if I have something in the tens digit and then in the units digit, that means 10 times what's in the tens digit plus 1 times what's in the units digit as my original value of that number. So if I had, I'm just going to try to make something up here real fast. Let's suppose I had 35 as my original number. That would mean T is 3, U is 5, TU is 35. It is not T times U 15. So far, so good with what I'm talking about there. This value would then be 10 times the 3 plus 1 times the 5 would be the value of that original number. A lot of these problems, not all of them, are going to talk about switch places. So if they're really thinking of 35 to begin with, when we switch it, it's going to be 5 times 3, which we know is worth 10 times the 5 plus 3. But they're not going to start off telling us the first number. They're just going to say we start off with a T and then a U, which is worth this. The T is going to be 3, the U is going to be 5. That can't change in this problem, even though we don't yet know what they are. So if the T is 3 and the U is 5, the original one is 10 times T plus U for its value. But when we switch places, it's now 10 times what used to be in the U spot plus whatever used to be in the t spot. Anybody with a question there? Because that's the whole idea of what we're going to be doing with a lot of these word problems. All right, help me out here, answer things quickly. Let's move through 2 examples. That'll be it before spring break for instruction. So we start off with some kind of a 2-digit number, and we know if we add them up, we have 7. Everybody okay with that for my first sentence? Okay, my original value, my original number is 10t plus u. If I switch it, it is now 10 times what was in the units digit before, and now what was in the tens digit is now in the ones digit, so just plus 1 times that. So that means our equation, when the digits are reversed, when it's switched, the new number is 10u plus t was 27 less than, so I had to subtract 27 from something, less than the original, which was 10t plus u. That means that I have one equation right here, t plus u is 7. I have a second equation here that has t and u in it. So I have a system of 2 equations, but I sure ought to clean up the one on the right. Everybody good with we need to clean up the one on the right? So let's get all of our u's and t's on one side and numbers on the other. Let's see what happens over here. If I subtract 10t on both sides and subtract u on both sides, I have 9u minus 9t is negative 27. Anybody have a good idea of how we might clean that up a little bit and make that a little bit simplified? What are you thinking, Ada? Let's divide by what? Let's divide everything by 9, and then we will have u minus t is negative 3. So that was my second equation. My first one is t plus u is 7. Would you guys all be okay if I switch that around instead of t plus u plus t is 7? Does that mean the same thing if I just switch the u and the t since they're both pluses? Okay, so there's my system. So go ahead and solve that. What does u have to be? What does t have to be? And then we're going to write it with the t spot and then the u spot to get our original number. So go ahead and finish this on your papers. Show me the steps for all of this. Recording and catch up to you. So let's see if I can get the same thing you guys just said you did. From this system, the t's cancel. 2u is 4, so u is 2. That means my original units digit is a 2. I also know that u plus t is 7. So what did you say you got for t? 5. So that's the first digit. So the original number was 52. Anybody with a question on that one? Okay, similar kind of problem, although this one is not going to involve switching the digits. We have a 2-digit counting number. So that means we have something in the tens place, and then we have some other number in the units place. That's not t times u again, just a tens digit followed by a units digit, and it has a value. So who can tell me the value of that original number? Yo-Yo, you want to give that a try? How do we write the value of the original number? What's the t worth? Who can help with that? What's the t digit worth? Anything in the tens place is worth what, Allie? 10 times whatever that number is. So that value is going to be 10 times t plus whatever's in the ones digit. Are we good with that? That's what it's worth. If there's a 3 in the tens place, it's worth 30. If there's a 7 in the tens place, that part's worth 70. Okay, so that value is 8 times something else. 8 times the sum of the digits. So if I have something in the tens digit, something in the units digit, I'm going to add those two digits up. So t plus u. Everybody good with that? Okay, we have a second equation in there. 6 times the units digit is 5 more than the tens digit. Who can tell me an equation for that? Nicole, would you give it a try? What do you guys think? Does that say 6 times the units digit is 5 more than the tens digit? So they're my two equations. Let's clean up the one on the left. 10t plus u is 8t plus 8u. Let's subtract the 8t on both sides. So 2t. Let's subtract the u on both sides. 2t is 7u. And I could do this with substitution or elimination, but what do you guys think? Would elimination be pretty darn easy over here? That the t would just be 6u minus 5. So if I let the t be 6u minus 5, and we have that times 2, and that's 7u, I'm going to pause the recording. I want you to solve that for u. And then once you have that, I want you to plug it in over here. What's t? And then write down the t one on the left, the u one on the right to give yourselves a 2-digit number. You guys said you guys got 72. Let's see if I can catch up now and also get that. 12u minus 10 is 7u. Subtract the 7u on both sides, and I have 5u. Add the 10 on both sides. I will agree that the units digit is indeed 2. T is 6 times that units digit, so 6 times 2 minus 5. 12 minus 2 is 7. So like you, I got that the tens digit has to be 7. The units digit has to be 2, so the original number was 72. Thumbs up, thumbs down in between on what we did today. And we will do homework for the rest of the period.